Hello, we are in Chapter 5, Section 5.8, the Pythagorean theorem and the distance and midpoint formulas. In this video, we are going to go over problem number 3, in which we are to find the length of the missing side in the following examples, reporting answers in exact form and approximate answers rounded to the nearest hundredth. We have 4 examples in here, and we will be using the Pythagorean theorem in all of them. Please recall that in the Pythagorean theorem, we want to label our legs as A and B and the hypotenuse as C. And with that labeling, the Pythagorean theorem states that the sum of the squares of the lengths of the legs A squared plus B squared is equal to the square of the length of the hypotenuse C squared. So in the first example, we have 3 squared plus 6 squared equals x squared, which is 9 plus 36 equals x squared, which is 45 equals x squared, and acknowledging that x represents the length, so it must be greater than 0, we will be only taking the positive square root of 45 for x. Notice that 45 is 9 times 5, 9 is 3 squared, of course, so we can rewrite the square root of 45 as 3 square roots of 5. That will be the exact answer, of course, and the approximated answer to 2 decimal places will be 6.71. We have to use the units, in this case, centimeters. The second triangle has also the lengths of 2 legs provided, so let's label the bottom leg A, the right leg B, and the hypotenuse C. So this time we're going to have 4 squared plus 7 squared equals x squared. Therefore, 16 plus 49 equals x squared. And 65 equals x squared. Again, x being the length must be greater than 0. So we only take the principal square root of 65. Now 65 is 5 times 13, and it doesn't have any perfect square factors. So it's already in simplified form, radical form, of course, but we can still approximate it, rounded to the nearest hundredth, to be 8.06. Again, centimeters, we always use the units if they are provided. In the third triangle, let's label the left leg A, the top leg B, and the hypotenuse C, and acknowledge that this time we are missing the length of the left leg. Still, the Pythagorean theorem applies the same way. So we have A, that means x squared, plus B, that means 2.7 squared, equals C, which is 8.6 squared. Now with the aid of calculator, we get x squared plus 7.29 equals 73.96. We are solving for x, of course, so we first isolate x squared, so we subtract 7.29 from both sides. That gives us x squared equals 66.67, and again x must be greater than 0 because it's the length, so x equals the principal positive square root of 66.67. That's the exact answer, and approximated to the nearest hundredth gives us 8.17, again centimeters. And the last triangle is really the most interesting of all of those, because we are not really given the length of any of the sides. All of them involve the variable x. We just know that the shortest leg has a specific length x, the longer leg is 2 units more, and the hypotenuse is 2 units more than that longer leg and 4 units more than the shorter leg. So let's label the bottom leg as A, the left leg as B, and the hypotenuse as C. So this time the Pythagorean theorem tells us that the square of x plus 2 plus the square of x is equal to the square of x plus 4. This is altogether a pretty big quadratic equation, that we solve by first expanding everything, then combining like terms and making it equal to 0, and finally using factoring to solve it. So we get the square of x plus 2, which is the product of x plus 2 with itself, plus x squared equals the square of x plus 4, which is the product of x plus 4 with itself. So expanding the left-hand side, we get x squared plus 2x and plus another 2x, meaning plus 4x, then plus 2 squared, which is 4, plus that other x squared, and on the right, we get equals x times x squared, plus 4x, plus another 4x, so that's plus 8x, and plus 4 squared, which is 16. So now to put everything on one side and combine like terms, let's subtract everything we have on the right-hand side from both sides of our equation and then simplify. So we have x squared plus x squared minus x squared, that's just a single x squared, then plus 4x minus 8x, that's minus 4x, and finally plus 4 minus 16, that's minus 12, equals 0. We try to factor the left-hand side. This one is actually pretty easy. It factors as x minus 6 multiplied by x plus 2, and using the zero product property, we get our two solutions, x equals 6 or x equals negative 2, acknowledging that x still is the length of our shorter leg. It must be positive, so it will be 6 units, and we discard the solution negative 2.